Okay, I'm going to go over Section E, and later on I'll do a video on kind of the configurator and more details about the configurator, but this time I'm just going to go through, assuming that you have this standard equipment, the recommended equipment, and that you've set up your transmitter and you have either a JR or a Futaba. So first thing you want to do is you start the configurator program. So we've already gone over getting that off the website, and just double click on that program to bring it up. Okay, now I'm just going to go over it. We have several tabs. We have the servo setup tab, which we'll probably spend the most time with. We have a pitch governor setup tab, and the V22, when you're in airplane mode or deep conversion angles, we run a pitch governor, and that adjusts the collective pitch as a function of airspeed. So this is the setup page for that. We have conversion curves. So as you convert your throttle, your servo volumes, or your endpoints essentially of your servos, move and change. And also we add collective pitch as you convert, and that's done here on this tab. Your gyro gain curves, also as you convert, your gyro gains change as a function of nacelle angle, and this is what that tab does. And we also give the ability to swap for any conversion angle from your rate mode to gyro hold mode. So we'll go over that a little bit when we get to this one. We have a landing gear tab. The landing gear kits are almost out. This is so the first thing you want to do is plug in your USB. The light will go green on the controller, and you can see that status becomes ready. The first time you're firing up your ship, you want to make sure that your conversion, your nacelle angle, is in the middle. And then when you plug in your connector, if it looks like your battery connector, if it looks like your nacelles are going to overextend and overrun into airplane mode and jam up, you want to disconnect that connector as fast as you can. So don't let go of that battery connector till everything stabilizes. And then you also want to make sure that none of your servos are just jammed up and humming, because these servos will burn themselves up if they're jammed. So my nacelles went to the mid position here, and I can hear a little hum, but that's just normal digital servo hum. I have nothing jammed up. So like I said, if you've got everything set up per the previous instructions and you're running a Futaba or JR radio, you should be able to flick your gyro gain switch, or the mode switch, and it'll switch between rate mode and heading hold mode. So if you take a look at the lights on these 520s, as I blue is rate mode and red is heading hold mode, and that follows the direction of the switch I want it to follow. So there's my switch on my transmitter. If the switch is working like backwards than you expect, then you would change the direction in the transmitter. And that's really all there is. Now if you're running a 401, and I do this with my 520s also, when you start up the ship, you start it up in hold mode, and then it initiates on the 401. It'll blink quickly, and when it initiates, the light will go solid. And I have noticed some problems, and with a lot of helicopters that sometimes you have to do it twice for the light to go solid on a 401 gyro. They just make sure you start it in heading hold mode with the 401s, plug it in, make sure you get a solid red light in the gyro, and then once you do, go ahead and put it back into rate mode. And that gets the gyro set up. If all your directions are right, this slider is going to be working correctly right off the bat. So as you move your slider on your transmitter from helicopter mode to airplane mode, and the way you move your switch is the way you want it, which on my transmitter I slide that. Like, this is helicopter mode and this is airplane mode. So it goes away from you to go into airplane mode. And you want to make sure that matches this slider up here, that it's working that direction. If not, you need to change the direction of the transmitter. The next thing we want to do is the conversion curve. So, well, if you think you're over, we should have had the conversion volumes set down to 50%. I'm going to go to the endpoints, or what they used to call volumes, and I'm going to scroll over to my AUG7 endpoint. Okay, there. And what you do is you go into full helicopter mode and you adjust your endpoint so your left nacelle is perpendicular to the wing. So that is actually my right nacelle you're looking at. The left nacelle is way over there. And I'm going to adjust the endpoint to where that nacelle is, that shaft is sticking perpendicular to the chord line of the wing. And then once I get that adjusted, I'm going to hit this set point here, and that'll store that position. Go into full airplane mode. You can see the slider moving. You want to set, so click in there. Now you want to set, when you're in full airplane mode, you want to set the endpoint such that your left-hand nacelle is parallel with the chord line of the wing. About right there. And then you want to go back to your configurator and set the airplane mode set point. And just hit that button. That'll save that position as full airplane mode. And then you can come back to helicopter mode. Now we want to match the right nacelle and the left nacelle. So this is the right hand conversion trim. So what you're doing here, basically, at every nacelle position in increments of 10, we're just trimming it so the main shafts are parallel to one another. And you can follow the conversion angle here as you change it, and you can look at the trim. You can adjust the trim position here. So the first one's helicopter mode, which is 90 degrees. I'm going to look across the ship. And I'm going to make the shafts. I like to look at the main shafts or the tops of the rotor head is what I like to look at. And I'm going to make an adjustment Okay, I'm going to make that adjustment in hover mode. Okay. You kind of see the other one in the background there. And then once I get that adjusted correctly, I'm going to go 10 degrees to the 80-degree point. You can be with just, you're close. So here I'm at 81. Then I'm going to make that same adjustment, and you'll see a trend developing. I'm going to slide 10 more degrees to 70, and I'm going to make that adjustment. Okay, I'm going to let you look at this side of the... I'm going to slide 10 more degrees. Now, if you don't have the slider, you're using a switch, you'll have to use your endpoints to work you through this stuff. I'm at 60. Make an adjustment. You can see a trend there. They're all pretty much going to be close to one another, or they're going to be, kind of shifting about the same amount. I'm going to go another 10 degrees. Sight the main shaft or the tops of the rotor head. Go another 10 degrees. At 40. So they're kind of slowly working up, it looks like. I'll get the 10. I'll go all the way into airplane mode. Okay, so these are all adjusted now. You can kind of see a trend where I'm slowly creeping up, and then I'm slowly creeping back down. And these two here are the same. And this really doesn't really need to be perfect, but you may want to go back and check. Like this one, it looks like it might have been a little high. They were both 20, so you can usually establish a pattern and kind of see that. But it also, in the same respect, it doesn't have to be perfect. Your cyclic servos are so powerful that this nacelle position really isn't that critical. As long as you're within 5 or 10 degrees, you'll be just fine. So I'll put it back into helicopter mode, and I may just go and double check that one more time just to make sure that that's set up right. But that basically gets your conversion trim, and then you can save to device right here, and it'll actually load that information into the device. If you don't do that, it'll never get stuck into the device, and then when you unplug your USB, your device will go back to where it was.